Let me introduce you to another member of the flight, Dr. Tammy Jernigan.
Thanks, Harry. Hi, I'm Dr. Tammy Jernigan. I'm in the Space Lab trainer here at the Johnson Space Center in Houston, Texas. I was the mission specialist on SLS-1, coordinating all the payload operations and carrying out the mission objectives, in this case working with jellyfish.
When people travel in space, we have to take our environment with us. We have oxygen, food, and everything else we need to protect us from the elements of space. When jellyfish travel in space, they need to take their environment with them as well. The jellyfish on board SLS-1 were placed in specially prepared bags filled with salt water and carried in an incubator to stabilize their environment. Just before we launched, Dr. Spangenberg and her students poured an iodine mixture into some of the bags to encourage the jellyfish's development. After all this planning, we wanted to be absolutely certain that the polyps would develop. By the time SLS-1 settled into orbit and we had begun our experiments, the jellyfish had passed their first important test with flying colors. They survived the launch, proving a smaller organism can withstand the forces of liftoff. To help the jellyfish polyps develop into Ephyra, we added the iodine mixture to another group of jellyfish. While we conducted experiments in the orbiter, simultaneous research was taking place on the ground by Dr. Spangenberg and her students. The Earth research is called the control, a setup that doesn't have the variable being tested. Every experiment should have a control because it gives you something to compare your results against. Both groups of jellyfish were videotaped as they swam in hopes of recording any changes in their movement or behavior. One of the most exciting changes happened almost right away. Remember how the jellyfish use their arms to pulse up and float down to feed on Earth? In microgravity, the jellyfish moved in circles, but they were still able to pulse and swim easily. In fact, despite being in a microgravity environment, the jellyfish polyps appeared to develop normally. After 9 days in orbit, we began to prepare the jellyfish for the trip home. One group was secured in the locker to be immediately studied after landing. The second group was preserved in a special liquid to be studied and compared to the jellyfish used in Dr. Spangenberg's simultaneous Earth experiment.
The information we gathered on SLS-1 will help us to learn how to fight the negative effects of space travel and pave the way for astronauts to stay in space for months or even years at a time. Pretty exciting, right, Ari?
You said it, Tammy. Boy, those 9 days just flew by.